Hi, in this video we are going to discuss two more metric. First one is AUC score, that's represent area under the curve, and then log loss. These things we will discuss in this video. In the previous video we discussed about the accuracy, precision, recall and F1 score. Now let's start with the AUC first one. AUC means area under the curve. The first thing that we have to know about the AUC score, we can only use this AUC score for the binary classification. And why we need basically this one? We have the accuracy, precision, F1 score, those are the metrics. Okay. First thing that we have to know, suppose when you using the binary classification task, we have some models like linear logistic regression, Navi base, another models also there. When these models generally from these models we will get the probability. From the models we will get probability. Once we will get probability, we will make some threshold value, like generally we will go with 0.5. By taking the threshold value, we will classify if the probability value is less than 0.5, we will classify that one as a negative point, and we can also call 0. The value is greater than 0.5, we can call as the positive class, and this one represented with 1. Finally, we will give the output prediction will be 0 1 like that, and on this we are going to apply this matrix, all metrics. But here if we change the threshold values, basically sometimes we are not get the actual probabilities, we are getting the some proportional probability. At that time it is difficult to only make 0.5 as a threshold value. By changing the threshold value, then also we will get the more performance from the model. That is the basic concept about the AUC score. Let's see how it's going to work. Suppose this is the data. The data X has the feature. This is the X feature. And the X features from the model we will get the probabilities. Okay, and we will generally with the threshold value, with the probability based on the 0.5, we will classify this one. Now in this approach, the first step here in the AUC, based on this probability we will sort this thing. The probability values has to be descending order. This is the first step. By making this probability value descending order, this all the things going to be changed, and finally we will get like this. And the next step is in the second step we will consider the various threshold values. Okay, here first start with this one is the 0.95 is the threshold value. If it is greater than greater than or equal to 0.95, this classify as positive. If less than that one, we will classify negative. T1 with 0.95. By this way, here 1 remaining all going to be 0. Now we have the values of zeros and ones. If we have zeros and 1, we can easily find the true positive rate and false positive rate. We already know true positive rate must be high and false positive rate should be less as much as possible. Then only we can tell that model is going to be very good model. With that threshold value, we are going to find with this T1 we are going to find the true positive rate and false positive rate. Okay, then next time we will take another threshold value. Now we will take threshold value as 0.93. Okay. By taking 0.93 as the threshold value, these two is going to be 1, remaining are going to be 0. Now for this also we are going to find the true positive rate, false positive rate. Next threshold value is going to be 0.95. T is 0.90. With this we are going to find once again TPR and FPR. By this way we are getting that for the 6 points we will get 6 TPRs, true positive rate values, and 6 false positive rate values. By using these true positive and false positive rate values, we are going to plot. Going to draw a plot. This one, let's go with that one. X-axis with false positive rate, and y-axis is going to be true positive rate. And the maximum value in this the area is going to be 1. You will get some true positive and false positive values like this. Okay. By this way we will plot this thing and we will find the area under this curve. This area is going to be a AUC score. The maximum area is going to be 1. AUC score is going to be 1, and the minimum is going to be 0. That means the minimum value is going to be 0, and the maximum value is going to be 1. Let's go with if we get a straight line like this. Suppose if we get the straight line like this, it is like a random model, and the value is going to be 0.5. If AUC score between the 0.5 to 1, then we can tell this model is good model. 0.5 less than or equal to 10, we can tell this one is a good model. If we get 0.5, then we can tell it's a random model. If we get less than 0.5, if we get less than 0.5, then we can tell this one is a worse model. But thing we can use when we get the value like 0.2 like that, we can reverse those things. For suppose from the model we will get the 1, we will convert this to 0. Similarly, if we get the 0, we will convert that one into 1. By converting this one, we will change the AUC score to 0.8, like 1 minus 0.22 is 0.8. 0.8 is very good AUC score. That means model is performing very good. And the best threshold value is a value when we will get TPR and multiplication of 1 minus FER maximum value. The threshold value when the TPR and 1 minus FPR is going to maximum, at the time which threshold value we got, that threshold value we are going to use to classify binary, that one. Okay. Now let's see about the log class. Log class also we can use both the binary classification and multi-class classification also. That's log class. Let's see why we can use the log class. Generally, if we suppose we will get the probability values from the model, if we apply the log to this one, we'll get some values. Okay, log 2.7, Generally, by applying the log, if the small change happen in the probability value, we are going to get that information. That means it penalizes the small change, small deviation in the probability values. It penalizes the small deviation in the probability score. Let's see the equation for that one. This is the equation for the log loss, that is equal to 1 by minus 1 by n, and the sigma equal to 1 to n. N is represent number of points. Log of pi, pi is the probability value, this probability values, and yi is the actual values. We will have, let's consider one more row will be, it's like 1 0 1 0. It's like these values, and then 1 minus yi into log of 1 minus pi. Pi also is the same probability. By this way we will get the log loss. And here the disadvantage is here we don't have the higher limit for the log loss. For the multi-level classification we are going to use 1 by sigma I equal. This is the for the this minus 1 by n sigma equal to 1, sigma j equal 1 to c. C is the number of classes by ij, log probability of ij. This is for the multi-class classification. This is for the binary class. This is for the multi-class classification. These are all the things about the AUC score and the log loss.